Okay, welcome again. We are going to be looking at this section today. Alright, we are going to be looking at this section today, anonymous functions. Alright, and under anonymous functions, we are going to be looking at lambda expressions, closures, and higher order functions. Alright, so says here that lambda expressions are compact syntax for defining functions without formal declaration, using the arrow notation to create inline executable code blocks. Right? So this lambda expressions, right, is another way we can write our functions. Okay, let me go back to this file where we started off with functions. Right, so I have a few functions here. Okay, all right, so what I'm going to do, another name for a lambda expression is arrow function. All right, let me just create a new file. Okay, so let me just copy this, paste. Usually we declare functions like this. This is a function declaration, we all know that. All right, but right now this function has only one statement. Right, it has only one operation to carry out, which is to print this name. Okay, unlike this one that has more than one operation. Right, it has more than one statement. It has about 5 statements, and the last of it is, okay, it has 2 variable declarations inside it, 2 print statements and 1 return statement. All right, and this one has 1 variable declaration and 1 return statement. All right, so we normally use lambda expressions. Another name for lambda expressions is arrow functions. Alright, so that's another name for lambda expression, and we use arrow functions because a particular function has only one is executing only one statement, or has only one statement to execute. Alright, and this is one way of making our code more efficient. Alright, when we reduce functions to lambda expressions to arrow functions, right, our code becomes more efficient. All right, so we do that by just, let me take out this comment, by removing the curly brackets and then pointing an arrow to the statement that we want to execute. Okay, so this is how to convert our functions to lambda expressions to lambda functions. Let me also convert this one to a lambda expression. I'm going to remove this volume and declare it outside of the function, and then return this. I'm just going to point an arrow to this value that I want to return. Alright, so that's That's it. And I can call any of these functions and still get my results. Okay, so this is still printing and this is still return sum. Now if I just call it, because there's no print statement anywhere, okay, I'm not going to have anything printed until I print this function. Now remember that this function has the value of this volume of this variable that we are returning from it. Okay, so I can print and get the same value. All right, so I can actually also convert the main function to a lambda function if I want to. All right, I'll just do the same thing. Okay, now the main function is also a lambda expression. All right, so this is just one way of making our code very efficient and simple. All right, now let's go over some things. First, let's go over anonymous functions. What are anonymous functions? Anonymous functions are simply functions without a name. All right, they are functions without a name, and they are usually passed as arguments or assigned to variables. So this is an example of one. Okay, so if I have this function, let me bring this back. So if I have this here, now I cannot have an anonymous function outside of the main function. I doubt I can. Alright, so I cannot. Okay, so if I want to do the only way I may be able to do this is if I store this in a variable fn. Okay, let me just simply use dynamic. Alright, so the only way I may be able to have an anonymous function in outside the main function is if I store it in a variable, in which case it is no longer anonymous, right? It actually now has a name. The name of this function now is fn this. All right, so I can even call it. All right, if I have something printed, if I have if I have a statement here, it will be printed. All right, so since an anonymous function is a function without a name, we cannot call this an anonymous function. I just gave it a name. All right, so it is no longer anonymous. A function can only be said to be anonymous if it doesn't have a name, like this one. All right, this is an anonymous function. Okay, so let's proceed. We have an example, a practical example. So, but just like I did here, right? If you ever want to call an anonymous function, now you can see that even I can't even execute the statement in this anonymous function because I still need to call the function, right? I'll still need to call this function even though it is already in the main function, but I cannot have a function. Sorry, in order to have a function execute, the function must be called. even if it is in the main function, right? And this is a function declaration. It is not a function call. So how do I call this function that does not have a name? Okay, the only way, if I really want to call this function, the only way I can do that is to, just like I did earlier, right, give it a name and then call. All right, so this function will now execute. All right, so that's what an anonymous function is. So we have an example here. We have a list, and then we are iterating through this list using a for each loop. Now this is another type of loop, right? I know we did loops earlier, okay, and we did for in loop, but there's another loop, another type of loop that is similar to for in, and that loop is for each. Right, so we are looking at this because an anonymous function is involved here, right? We are looking at where an anonymous function can be used, and one of the places where an anonymous function can be used is in the for each loop. All right, so let's say we have a list of numbers. Okay, let me just copy that. A list of type int numbers, right? So this is we have this right here because the type of data that we want, the type of items that we want inside our list are int. We do not want any other type other than integers in our list, right? So if I dare to put a double here, for example, I'm going to get an error because this list is of the type int. Do you understand? Right, if this list we are of the type string, all these items are going to throw an error. Only strings will be allowed to stay in this list. All right, only strings will be allowed if it were of the type string, but it is of the type int, so only integers are allowed in this list. All right, so that is extra knowledge. So now we want to do something with this list. Let me add more numbers, 4 and 5. All right, so we want to let's say we want to print, first of all, we want to print every number in this list. All right, so I can do that with a for in loop, right? If you remember what we did in loops. So for int x is going to represent all the numbers in this list, right? So I'll say in numbers, all right, print x. Okay, so this is me using the for in loop to print all the numbers in the list. Okay, I can even multiply them if I want, or do whatever I want to do with them. All right, so this is for in, right? But I want to use for each to explain anonymous function. So the for each loop looks like this: numbers dot for each. Okay, and then inside of here, now this for each, if you look at the definition, right, the definition of this function, you will see that it takes another function as a parameter. All right, it takes another function as a parameter, and this function um, we will have to pass in an int, right, an integer, as a parameter of this function that this for each takes. Okay, so let's proceed. Numbers dot for each. Okay, numbers dot for each. Number. All right, so print number. So just the same thing that we had in the for in loop. All right, so this is an example of an anonymous function. All right, this is one place that an anonymous function can be used in the for each loop. All right, in the for each loop. So let's proceed. Assigning an anonymous function to a variable. We have already done this, right? We created an anonymous function, right? We created an anonymous function, and in order to call the anonymous function, we had to assign it to a variable. We did something like this. Okay, and then in order to call it, we just assigned it you remember. All right, so that is what is going on here. We have talked about arrow functions, right? And this is another example of lambda expressions. Arrow functions, what are they? They're a shorter form of anonymous functions used when the function has only one expression. Okay, so we have an example, and this we have looked at already, but we didn't look at it with the parameters. All right, so let me just paste this up here. So we have an anonymous arrow function here. All right, so when this function is called, let me try and understand what is happening here. Yeah, it's an anonymous arrow function. Okay, closure int. All right, so why I am having this is because I have not called this function. Remember what the function call looks like? It looks like this. All right, it looks like this. So, and now that I have provided this parenthesis, I need to add two arguments to represent this a and b. Okay, so I'm going to add 1 and 1. Okay, for 1 plus 1, and 1 plus 1 is 2. All right, so if I did 1.1 plus 3 is 4, so a plus b is being returned to this variable via this anonymous function. All right, so that is why we have 4. All right, we have already looked at for each. All right, so this for each can actually be rewritten like this. It can be written as an arrow function. Okay, it can be rewritten as an arrow function by just removing these curly brackets and attaching an arrow. Okay, and it's going to run the same way. Okay, so it says here we get the same result when we use lambda functions, and lambda function, the use of lambda function is cleaner and preferred. I agree with that. Okay, so now closures. What is a closure? A closure is simply a function that remembers and uses variables from its surrounding scope even after the scope is gone. Okay, a function that remembers and uses variables from its surrounding scope even after that scope is gone. So we have a simple example. Actually, I would like to look at this in a separate tutorial. All right, so let's end this class. We have already talked about anonymous functions and lambda expressions, right? So the next lesson will be on closures.